In general, the reaction of an acid and a base produces water and a salt. And it's just a class of compounds that are called salts. And we'll use a really basic, obvious reaction for this one, which is hydrochloric acid and sodium hydroxide. When they react, we've got a strong acid and a strong base. We get a salt and water, and we quite literally get salt, NaCl, which is table salt. So acid plus base makes a salt and water. And if all you have is salt dissolved in water in the end, what you have is a neutral solution or neutralization, and it should have a pH of 7, which is the neutral pH. When an acid and a base are mixed, the equivalence point is when the number of moles of hydrogen ions equals the number of moles of hydroxide ions. So they are equal, which is why we call it the equivalence point. So this is a neutral solution with a pH of 7. Indicators are often used to determine when enough of the standard solution has been added to neutralize the acid or base. Now the point at which the indicator actually changes color is the endpoint of the titration, and a titration is a process where you're adding acid and base in measured amounts. And the endpoint here is actually when you've gone just slightly to the base side, usually, and the indicator will show that. So the process of adding a known amount of solution of known concentration to determine the concentration of another solution that's unknown is called titration. The point of neutralization is the endpoint of the titration, and the solution of known concentration is called the standard solution. So in our lab, where we used a strong acid, strong base, the standard solution was the base because we knew what the concentration was. So here are the steps of a titration. First, you have a measured volume of an acid solution of unknown concentration in a flask. Then you add several drops of indicator and swirl the solution as you add more of the chemical. So you're adding a measured volume of base, so you have acid in the flask, and then you're adding base from the burette into the mixture until the indicator just barely changes color. And that's going to tell you when you've hit the neutralization point. The equivalence point, where we have equal concentrations of hydrogen ions and hydroxide ions, is not exactly the same as the endpoint. The endpoint is where the indicator changes color. The standard solution should change the indicator color so the endpoint can be determined. So when you're choosing an indicator, you need to make sure that it will change with your solution that's in the burette. So our example would be phenolphthalein is a really great indicator with a base. It turns hot pink. So the endpoint will be measured when the solution turns pink, and the solution in the burette is what will turn pink with the indicator.